Hi, welcome to another edition of Science Class Notes. Today we're looking at redox half equations and transition metal titration reactions. Here's a question I found. It's an older question, I think. However, I've missed out some parts of it, but the question starts off with hydrogen peroxide used as an oxidizing agent in the preparation of transition metal complexes. Now, interesting thing about hydrogen peroxide is it can act as an oxidizing agent, but also as a reducing agent, which I'll cover in other editions as well of these science class notes. So you can have a look on there and see work some stuff out on hydrogen peroxide. However, let's get on with this. Here I wanted to show you this question because this was a fuller question. It's an older question, so there's lots of bits in this which aren't relevant to your current specification. So I've just gone straight on to the part C of this of this question, and here this involves balancing half equations, combining half equations, and then using that to actually complete titrations. So this is the full question in its entirety. It's worth 5 marks. So mark a minute roughly. So 5 minutes per mark, 5 minutes for the 5 marks. You can pause the video as usual, or you can stay with me and I can talk you through it. So it's up to you what you would like to do. So if you want to pause now, go ahead. But if you're staying with me, then let's proceed with this. So let's have a look at this question. This question is involves 2 bits mainly, but there are lots and lots of parts to it as such. But the first thing they want you to do, so if you read through the question, they've said that they've used a hydrogen peroxide solution. You can determine the concentration of hydrogen peroxide solution by titrating against acidified potassium manganate 7 solution. In this reaction, they've told you that hydrogen peroxide is oxidized to oxygen gas. So this straight away just shows the dual role that hydrogen peroxide could have. Sometimes it could behave as a reducing agent, sometimes as an oxidizing agent, as here, because itself is reduced. So here is a reducing agent. And you must know that potassium manganate 5 solution is actually an oxidizing agent. So here, in the presence of an oxidizing agent, hydrogen peroxide will reduce itself and act will oxidize itself, and act as a reducing agent. Okay, so let's have a look. We've got 5 cm cubed sample of hydrogen peroxide solution was added to volumetric flask and made up to 250. Okay, so in fact, you've diluted the hydrogen peroxide here, taken a small portion out, and then you've acidified it, reacted completely with potassium manganate solution. Right, so what they want you to do then is write the equation for the reaction. So that's the first thing we'll do, and then secondly, what they wanted you to do was use the balanced equation to calculate the value for the concentration of hydrogen peroxide. So let's start with the first bit. Of course, you can pause the video at any point you wish, and you can have a look from there. So let's see, let's go on with the half equation first of all. Let's do the easier equation, I guess, which one you should know. Let's go for the manganate one. So you've got to know that potassium is a spectator ion in this, so we can leave that out of the equation. So what happens here? We've got potassium manganate 7. You should have an idea that this actually goes to that. Okay, sometimes they tell you in questions, sometimes they don't, but you must be aware that the oxidation state of Mn here is +7. How you work that out is very easy. It's oxygen is -2. There's 4 of them, so it's -8. So just like solving for x, x plus -8 equals -1. This must be +7. Okay, then it goes to +2. So what's happened to Mn before the arrow to after the arrow? Well, if it's the positive charge has got lessened, the only way that could happen is by gaining electrons. In fact, 5 electrons here. So it's gained 5 electrons to make Mn2+. Right, so let's have a look now. So that's the first part done. The next part we need to consider now is, what about the oxygens? What happens to those? Well, we know this is an acidified solution. It has to be acidified because the oxygens won't just disappear. Because I've got 4 oxygens here, I've got 4 oxygens on this side. But where do the hydrogens come from? And that's, of course, the acidified solution. And there I've got 8. So this is your first half balanced equation. You can check if this is balanced by, first of all, considering the particles before and after the arrow, and then the overall charge before and after the arrow. So here I've got 1 mole of Mn, here 1 mole of Mn, 1 O, so 1 capital O here, sorry, 4 capital O's here, 4 capital O's here. I've got 8 H's, capital H's here, 8 here. So they're balanced. Overall charge on this side, well, 5 plus minus 1 plus 8 equals plus 2 on this side, and here plus 2. So we've got a balanced equation. We've done that check. The second part of the half equation is involving this stuff, hydrogen peroxide. They've told you here what's happened to hydrogen peroxide. Hydrogen peroxide has turned into oxygen gas, O2. So let's have a look over here and let's see what happens with that. So hydrogen peroxide is H2O2. They've told you this happens. Now, same as before, got to be a bit careful here. Oxygen and hydrogen peroxide is actually, its value is -1. It's not -2. It's one of the rules that you must know about, which I'll cover in one of the videos. So each oxygen atom is -1. Here it goes down to oxidation state 0. So what's happened here? It's lost an electron. So each oxygen has lost an electron. So that makes it lose an electron. So let's have a look. We've got 2 capital O's here, 2 capital O's here. That's fine. But because there's 2 particles of oxygen, we've got to put a great big 2 here. Now we need to account for the hydrogens. What happens to those? Well, the best way to look at this, overall charge before the arrow is 0. The overall charge is -2. So to balance that, all I need to put is 2 H pluses. Now that's a balanced equation now. 2 H's here, 2 H's here, 2 O's here, 2 O's here. Overall charge is 0. Overall charge is 0. So that is a completely balanced equation. Now all we need to do is cross multiply by the electrons on each equation, and then we can write a full balanced equation. So here I've got to multiply the whole line by 2 because of this, and the bottom one I need to multiply by 5 because of the 5 electrons there. So once we add everything together, we should have, let's have a look. So we've got 10 electrons plus 2MnO4 minus plus 16 H pluses plus 5 H2O2 going to 2Mn2 plus 8 H2Os plus 5 oxygens plus 10 electrons plus 10 H plus ions. Wow, that's a long equation. Okay, let's have a look. What can we cancel off? What can't we cancel off? Well, just looking at this straight away, we can get rid of the electrons. So these electrons will cancel these electrons. Let's take a look then. So I've got 2 Mn before the arrow, 2 Mn after the arrow. I've got then 8 oxygens here plus 5 lots of 2, so 18 oxygens on this side. Here, let's have a look. I've got 8, add 5 lots of 2, so 10, so 18 again on this side. Oxygens are balanced. I've got then, let's have a look. I've got how many H pluses? I've got 16 H pluses there, plus 5 lots of 2, so that's 10, 26 on this side. And oh, I can do something with these oxygens actually. Let's get rid of some of these. So 10 of these will cancel 10 of these, so I'm left with 6 on this side. Much easier to handle. So I've got 5 times 2 is 10, add 6 is 16 on this side. 8 times 2 is 16. There you go, that's balanced. And then oxygens, then we've got also 4 times 8 on this, 4 times 2 times 4, that's 8. And over here we've got 5 times 2, which is 10, added together there, that's 18. And over this side, 8 times 1, so that's 8. 5 times 2, yep, all balanced. So that's all balanced. The charges then, again, same manner, 2 minus plus 6 over this side. And over this side, I've got 4 plus, that's it, 4 plus. So then that's a balanced equation. Okay, if you're not sure how to do that, maybe you want to stop the video and go through it again. It's not a problem. But I'm going on to the second half now, which is here to consider the calculation now. We've got a balanced equation. There it is. We're going to use that for the ratios when we're calculating these things. But let's have a look at the numbers. Let's see what the numbers are saying. Now, my advice to you is as always, is to decode these numbers. What does that mean? Well, that's a volume of something. We can tell by the unit. That's a volume of the H2 hydrogen peroxide. There we go. And over this side, the next number along here is I've got 250 cm cubed. Okay, so we made it up to 250 cm cubed. So I want to join that to that one. So we started off with 5 cm cubed. We've added some acid to it, etc. And then we've actually increased the volume because you can't titrate 5 cm cubed. So you need to make it up to a reasonable volume. And then, in fact, they've taken out 25 cm cubed. 25 cm cubed of what? Again, it's another volume. Let's call it vol of H2O2 again. Let's read on then. And that was completely acidified, completely reacted with, there we go. We've got a volume again. There it is. Now, what is this a volume of? This is a volume of, this time, the MnO4-. The next number along here, there we go. Once again, got a conch this time, again of MnO4-. Just looking at the numbers now, we can see that the only thing you can absolutely work out is the moles of something. And in fact, it's the moles of our manganese. Okay, so let's have a look. So the only thing I can do then is N is equal to CV, which is equal to 187 multiplied by the volume then, which is 24.35 times 10 to the minus 3. If you do that calculation, then you should get an answer of 4.55 times 10 to the power minus 4 moles of MnO4-. Now, how many moles of potassium, how many moles of the hydroxide do we have present? Well, we can work that out from our balanced equation. We've got a ratio of 2 MnO4- to 5 H2O2. So therefore, all we need to do is take that number, 4.55 times 10 to the minus 4. Got to divide that by the 2. So divide by 2, multiplied by 5. Should say 5. Then the answer should come out as 1.138 times 10 to the power minus 3 moles of the hydrogen peroxide. Now that's in the titration mixture. Now we've actually taken a small portion of the original, haven't we? So we've got to work out the actual moles that were in the of H2O2 in the 250, because we've diluted it. Okay, so we've taken out a small portion. Now we've got to work out how much of that portion we've actually titrated in that small concentration. Well, if you look at this, we have 250 cm cubed. That's what we took it from, and the portion we took out was 1/10. So if you like, 250 divided by 25 gives you a factor of 10. So therefore, in that amount, you've got in the number of moles that are in the reaction mixture, there are actually, in fact, 10 times less. So what you need to do then is multiply 1.138 times 10 to the minus 3 by that factor of 10, giving us the precise amount. Okay, 0.011384. moles. And that's what we had in our original sample. Now from here, we are ready now, finally, to work out the concentration of H2O2. We have a volume, there it is at the top there, of 5. So once again, N is equal to CV. Rearrange it to make C the subject. And then we use the numbers 0.011384 divided by, well, 5 times 10 to the power 3. Once you put those numbers in, you'll end up with a number that is 2.2768, which we can round down to 2.28 mole per dm cubed. And that's how you work out the concentration. Now, as you were doing that, did you notice that each time you made a calculation, you actually just carried that number forward? You didn't zero your calculator. You didn't have to start again. So a useful tip there is when you're doing these types of calculations, these titrations, do make sure that you carry the number forward. If at any point that in your calculator you do need to zero it, then you've probably done something wrong. So go back through the calculation to work it out. Here is the mark scheme. I hope this video helps you. Please do encourage your friends if they need help with this to watch the video. Please do like and subscribe as well.